Okay, hello. Today I'm going to show you another two MOC, and these are two MOCs. There's two fan blades, but let's push that away. So anyway, if we look at these two MOCs, there are pretty cool mechanisms. The first one I'm going to start with is this one. So let me connect the motor. Okay, so let's power it on. Wow, this turntable is only spinning a little bit. There's a delay for the rotation. So let's look at the mechanism. So if I did not, this is a very slow, is because I have a worm gear connected to a 24-tooth gear, which is then connected to this gear. Otherwise, this mechanism will go very fast. You couldn't even see what would be happening. So on the flip side, we can see that there's a thing called eccentric cam. An eccentric cam is basically you have a circle and the rotation axis is not in the center, so it'll have a weird rotation. Then we have a 28-tooth, it is a turntable, and whenever the eccentric cam touches the turntable, then it will turn it a little bit when it is contacted. So once it pulls out, then there will be a delay of the rotation. So you can see that. Turn it on the other way. The eccentric cam rotates the other way. Notice how it's not rotating on the center, like say this 24-tooth gear. So this is a cool mechanism. I don't know what it might be used for. Maybe something that you might have to have a delay before you want it to work. Let's look at the next model. This model is a combination of a lot of things. So in the model, we can see that So the motor is connected to a worm gear, and it is connected all the way to a 20-tooth double bevel. The worm gear inside meshes in the frame with the 8-tooth gear, which is then connected to a crank here and connected to a 12-tooth gear, double bevel gear here. And on the top, there in the frame, there is a 24-tooth gear meshing with the worm gear, which is connected to nothing on this side, as the rotation is free for this yellow 2-unit beam. And there's also a 36-tooth gear. And this is something trying to form the gear ratio same. So I noticed that you can create two 1-to-3 or 3-to-1 gear ratios. One is with an 8-tooth gear and a 24-tooth gear, and the other one is a 12-tooth and a 36-tooth. Both of them can mesh together on a straight beam, but they cannot mesh with each other on a straight beam. So again, the 24-tooth can mesh with this 8-tooth on a straight beam, and the 12 and the 36 can, but for example, the 36 cannot mesh with a 24-tooth. The 12-tooth cannot mesh with an 8-tooth, things like that. So on here, connected to this 20-tooth double bevel, there's another 20-tooth, and this is a spacing method, so it is a 1-to-1 gear ratio. On the back, this is a form of 4-bar linkage. So as you can see, there's a lot of concepts and ideas. The other thing I wanted to say that it's because some fan models, like in an oscillating fan, they had a worm gear mechanism for rocking back and forth, and the worm gear power is connected to a fan. I have prepared 3 fan blades to spin. The first one is like this. The second one is like this. The third one is like this. So I'm going to power on each one of these, and let's see what happens. So this creates a lot of wind, and you can see when the motor's being driven, the 4-bar linkage is also being driven. And this is sort of a compound gear thing. This gear is connected to this, and this gear is connected to that. And you might be thinking the worm gear might be an idler gear, but it is not really. The worm gear, which side you are on for the worm gear, decides what direction you're rotating. So this meshing will work, as you can see. So I got the wire stuck. Give me a second. Okay. So anyways, you can see that this gear will turn the slowest. I added this sort of fan indicator thing to show you. Well, this is very fast. So let me attach the other fan heads. So this one will produce less air, but doesn't take up that much space. And then there is this one. So this is a lot of different functions MOC. Anyway, goodbye.